All right, we're going to take a different approach this time. I have my solution made, I have my explanation ready, and we're just going to blast through it really quick as opposed to my usual of trying to solve it live. 62 unique paths. There is a robot on an M by N grid. The robot is initially located at the top left corner. The robot tries to move to the bottom right corner. The robot can only move either down or right at any point in time. Given those two integers, return the number of possible unique paths that the robot can take to reach the bottom right corner. So, here's here's what that looks like. If you're this robot, you can go all the way to the right and then go down, or you could go all the way to the right by what was it? Except for the last one, then go down, then right, then down, or you can go all the way and then go all the way down and then one more to the right and so on. So it's you got to figure out a formula to or a program to calculate how many possible routes this robot could take. So this problem is a good example of just whittling the description down to its core features. I feel like honestly there's a red herring here by showing you a 2D array. It would make you think that maybe you got to simulate the robot, from as a 2D array, but that's unnecessary. We can just break this down into what it is, which is just a simple math formula. So, the way I started thinking about this was if we have right, down, 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 right, down, that's just three different combinations of the same two elements, two downs and one right. That's three different combinations. So it's just a matter of how do we calculate the number of combinations given, the two elements. And from there, I just remember that you could just use binomial combinations. It started, my original solution was to maybe like use binary because it's either down or right. I could maybe represent down with 0 and right with 1 and count up until, if it's like, that would be like 0, 1, 1, 1, 1, 0, 1, 0, 1. Basically, I would just count up and then record any time that there were the proper number of ones and zeros, but that was just a lot of unnecessary calculations. We can just calculate essentially t choose k, where t is the total number of possible moves, is the total number of moves at the end of the day, and k is the number of either the right moves or the down moves. Here, let me show you. And commented it out. So we're going to try to find t choose k. T is the total number of moves. For example, in example 1, it's required to go right 6 times and down twice because we start at 0, and so it's 0, 1, 2. So we don't need to move to the spot that we're already in. So it's 0, 1, 2. So it's just 1, 2. So that's 3 minus 1, so it's m minus 1. So you do m minus 1 and n minus 1 to account for you starting on the first space, and then you add those up. You get m plus n minus 2 for the total. All right? And then k is the lesser of the two move counts. So for example, if r is 1 and d is 2, we have three possible routes: RDD, DRD, DDR. All right? So now that's just essentially t choose k, because you're counting all of the possible ways that you could choose k elements from t. That's combinations at the end of the day. If you have 10 people, how many different combinations of 2 can you make? All right? Do you want the first and the second person, the first and the third person, the first and the fourth person? It's the same issue. All right? So like, for example, if r was 2, then this is what we got. And that equals the binomial combination formula. I'm using t. Traditionally, it's n, but we already have n here as one of the parameters. So we're going to be using t for total. So not necessary, but I like to label it just to be clear. So we have the number of down moves you have to make is m minus 1. The number of right moves you have to make is n minus 1. And the total is down plus right, or m plus n minus 2. Now, it's easier. You're going to do less. N, since it's binomial, it's symmetrical. If you had 10 people and I asked you to choose 2, there are as many options as if I gave you 10 people and asked you to choose 8 of them. Okay? Because it's symmetrical. Because essentially when you're choosing 2 people, you're also choosing the 8 people that don't get chosen. So those have to equal each other. But for simpler calculation, we want to work with smaller numbers because we're going to be doing factorial. Now, if we're writing it down on paper, we want to do the factorial. The factorial of the numerator and the denominator, or further to be clear, t factorial over k factorial times t minus k factorial. Factorial, as you know, is all about, well, as you might know, is all about canceling things out. That's one of the most that's like one of the most of the most basic math operations. Factorial is one of the most costly, because you had to do O(n) operations where n is just the number itself, essentially, or actually O(n) minus 1, because you don't need to really worry about multiplying it by 1. Regardless, let's work on simplifying this formula. We can also make it a little bit bigger. If we have t as 5 and k is 2, so if there's a total of 5 moves we have to make, and k, let's just say the downs, is 2, so we have to go down twice and right 3 times. Then of the total possible paths, of the total possible, what's the word? Of the added up number of down moves and right moves, that's 3 plus 2, because we had to go down right and 5 down twice and right 3 times. That gives us 5 for the numerator, and we're choosing 2 of them to get the same thing as what are the combinations that we can fit the 2 down moves into the other 3 right moves. So we have 5 times 4 times 3 times 2 times 1. The k is 2 times 1. And then the t minus k, the t minus k is 3 times 2 times 1. Essentially, we can just wipe out this and wipe out this. Now we just have 5 times 4 over 2 times 1. And this works with other numbers, even if k was bigger than half of t. Then so we cancel it out, we get that. Now, we can, what we're going to do is calculate those numerators and denominators and then just perform that operation at the very end. And we've wiped out more than half of the number of operations, because we have 5 times 4 times 3 times 2 minus 1, times 1. Now it's just 5 times 4. So to calculate that, it looks like this. Now this is clever. It's not the most accessible, but I can explain it. That's what you got me for. We're going to calculate the numerator by saying, okay, so we have the numerator and we're multiplying it every time. So we're saying, okay, numerator starts at 1 because we're multiplying it, so you need to give it a good base value. And we're saying, okay, It's the total moves minus I minus 1. Actually, maybe it'd be easier to start with the denominator, because the denominator, we're actually just going to go backwards. Because with factorial, you count backwards. You go 2 times 1 if you're doing factorial 2, because you do n times n minus 1 times n minus 2, so on. But we don't have to, but by just basically performing them at the same time, the numerator calculation and the denominator, we go backward with the numerator and we go forward with the denominator, but forward is actually backward since we're calculating the factorial by multiplying up. So we'd start, if k is 2, then for I in range 1 to k plus 1 is 3, but it's exclusive, so it's 1 to 2. Denominator gets multiplied by 1, and then 2. Bam. Denominator is done. The numerator is the total moves, which is 5, minus I minus 1, so that we don't subtract from it right away. So 5 minus 1 is minus 0, so we get 5. And then we get 5 minus 2 minus 1 is minus 1, so that's 4. And then that's the end of the loop because we just did it twice. And then we just return the division. That's it. That's all it is. That works for all the possible things. There we go. We submit that. Yeah. Actually, a prior submission did even better. Yeah, look at that. So, that's a great problem. It's a matter of just breaking it down into its core values. Breaking down the problem into just being a math problem, and then breaking down that math problem into being an even simpler math problem. There we go. Thanks for watching. I hope this helps. Let me know what format you prefer if you're watching these. Thank you so much. Have a great day.